All right, guys, this is going to be section 5.5 and 5.6, properties of parallelograms. Some goals that we are going to pick up throughout this lesson is that you're going to learn all the different properties of parallelograms. There's going to be some special parallelograms, so you'll learn about those too, and just be able to solve for sides and angles in these parallelograms. So let's review from chapter 1. What is a parallelogram? It's a quadrilateral with opposite sides parallel. So there it is right there. Most of y'all are familiar with this. And then when opposite sides are parallel, we also talked about this in chapter 1, is that if they're opposite, if the sides are parallel, then it forces opposite sides to also be congruent, okay? So you need to kind of remember that this side is going to be the same exact length as that one and the same as that one, okay? And we talked about that back in chapter 1. Okay, so let's talk about some other parallelogram properties, and when we throw in the diagonals, okay? So we're going to construct a parallelogram first, and then that way we have a perfect drawn to scale parallelogram, okay? So let's draw a longer side on the bottom, and then let's just pick a random side length. Oopsie, undo. Okay, like so. And then to get the exact sides opposite parallel and congruent, we're just going to measure. Bring this to the front. So I'm going to put my compass on this bottom end. And of course, that's too big. So let me erase some of that. There we go. And then, so I have the exact width there. So I'm going to come over here and put the exact width right there. And then I know that this side is going to be exactly the same size over here. And again, we learned this back in chapter 1. So I got that width right here. So I'm going to come to this vertex here and make an arc there. So now I'm just going to get my ruler and connect there to there. I'm not sure. All right, one more time. My ruler is malfunctioning. I'm not able to draw on it exactly. There we go. And then let's draw that other segment. And then once you do that, just make sure that you draw your diagonals. So now I'm going to put my ruler here, connect it to there. So we're drawing the diagonals. I'm just going to pick a different color. Let's do blue. So from there to there, and from here to here. Okay, so my ruler's not working, so I'm just going to use the segment tool. So y'all just bear with me. All right. So make sure they are right at each vertex. Okay, so we have a perfect parallelogram. Remember, opposite sides are congruent because we already knew that, so I'm just going to mark those. And now I have both diagonals drawn. And then it says measure all the angles with your protractor. And then it says measure the diagonals in centimeters. All right, so let's measure each angle with our protractor. And you want to make sure that your diagonal is right intersecting. If not, you may want to redraw that. So this one, And feel free to pause the video and measure your angles as I am doing so right now. So that whole angle is 85. So 85 minus 28, which makes this one 57. All right, let's go over here and measure these. So this bottom left one looks like it's about 37. And that looks like right at 115. I'm sorry, 105. Let me make sure I got that right. Yes, 105. So 105 minus 37 equals 68. Let me go back and measure the ones on the left. I think I might have measured incorrect. It's 75, not 85. So that one was wrong. So 75 minus 28 equals. So just this whole angle right here was 75 degrees. This whole angle over here was 105 degrees, okay? So now let's go measure up here, up at the top. So this whole angle, oh, what do you know? It looks like it's 105 degrees as well. So I'm just gonna write 105 over here. So that's a unique property, matches on the opposite end. And then over here we have about 37. Wow, that matches up too. So this was 37 degrees here, which forces this one to be 68. All right, so we got a coincidence right there. We got something matching up. Let's look over here on this end. This one is about 75 as well. So this whole entire angle is 75. Let's measure each one. This one is not drawn perfectly, so I bet it might be a little off. Nope, it's right there. That one's 28 degrees right here. And so if that's 28 degrees, I already subtracted because that one was 75. So this one is 47. So those are some unique properties right there. Okay. All right. Some other things to measure. It says measure the diagonals in centimeters. So I'll let you continue with that. And let's measure each diagonal. Now there's an intersection point right there. So we should probably make note of that. So let's see, that entire diagonal looks like about 7.8. And this looks like 3.9. So if the whole thing is 7.8 and this is 3.9 right here, then that forces this to be 3.9. Okay, because the whole diagonal was 7.8, just did subtracting. All right, let's measure this diagonal here. So this whole diagonal looks like about 10, and that's right at the 5. So 5 and 5 make 10. That was 5 centimeters, and that's 5 centimeters. All right, so those are all the properties right there, and they all came out just as they should have. You can see that these are congruent right here. Let me get my highlighter to point some of this out. So this 37-degree angle was the same as this one here. Okay, this 28-degree angle was the same as this 28-degree angle here. This 47-degree angle was the same as this 47-degree angle here. And this 68-degree angle was the same as this 68-degree angle here. And then you should have realized that, oh, wow, this point right here that I just highlighted in pink, that is the midpoint for each diagonal. Now, of course, one diagonal is longer than the other, but you still see that this one was 5 and 5, and this one was 3.9 and 3.9. And it's because we constructed that. So these are all the properties that you're going to need to know. So it says opposite angles conjecture. So the opposite angles, oh, we even marked those, okay? Remember, this one was 105, and then this one was 105. This one was 75, and that was 75. So the opposite angles are always going to be congruent, okay? The consecutive angles in a parallelogram, these consecutive angles, so like these two right here, these are consecutive, okay? These are consecutive. These two right here are consecutive. What do you notice about the consecutive angles? And then, of course, that top pair. Consecutive angles, 105 and 75, those all add up to 180. So the word that describes that is the word supplementary. Okay, and then lastly, the diagonals of a parallelogram, well, we discovered that with that midpoint. So the bisection is what makes that a midpoint. So they bisect each other. All right, so these are all the properties that you now have to know. Just to kind of make it a point, these two pink angles, those are alternate interior angles, and of course they're between two parallel lines. Therefore, that's why those are congruent. So is the green pair, so is the orange, and so is the blue pair. Those are all alternate interior angles. All right, so you're going to be given a parallelogram on your homework, and you're going to have to solve for angles and side lengths. All right, let's go to this next one. It says, what can you draw with a double-edged straight edge? So on your paper, use a double-edged straight edge to form two pairs of parallel lines, and then construct the diagonals. Okay, so let's get our ruler, hold it down, and I want you to draw a set of parallel lines. And then I want you to turn the ruler at a diagonal or just slanted and draw another set of parallel lines like that. Okay, so the polygon that we're looking at is polygon A, B, C, D. Okay, and it says draw the diagonals also. So let's get our ruler and draw those. I was having trouble last time, so I'm going to use my segment. So connect the diagonals with your ruler, and let's try it again. There we go. Try to be as precise as possible, perfectly at each vertex. Okay, and if you're a little off, move it over so it goes perfectly to the vertex. All right, so we got both diagonals drawn, and it says, what do you notice about all the side lengths? Okay, so I'm going to get my compass out, and I'm going to show you the width of each side length. So I'm going to measure from here to here. All right, and then I'm going to swing it over like this. I didn't change the size. It's the same exact size as that one. Okay, pretty sure that if I come over here, look at that, it's the same exact size there. Okay, there, and then that one down there at the bottom, which I already did. The only one that I didn't measure was this one up here, but looks like it's right on the money again. All right, so all of those are congruent, so let's mark all those congruent. This is congruent to that. Okay, and so we just made two pairs of parallel sides that are the same distance apart, so that forced all the side lengths to be congruent. Okay, the other thing I kind of want to measure is the diagonals, okay, because it said measure all the side lengths. So let's take a look at the diagonals, which actually, before we do that, let's look at this. It says if two parallel lines that are intersected by a second pair of parallel lines that are the same distance apart as the first pair, then the parallelogram is a what? This one is going to be a rhombus, okay? So I just made parallel sides and all of them are the same distance apart, so therefore it forced all four sides to be congruent. So this is a parallelogram, and it's a special parallelogram that we're going to call the rhombus, okay, which we talked a little bit about in chapter 1 as well. And so all the side lengths are equal in a rhombus always, okay? Then it says something about the diagonal. So it says, measure the intersection of the diagonals, okay? Measure the angle at the intersection of the diagonals. So you get your protractor and you put it right on the intersection. Of course, you want to line it up with one of the sides. What do you notice? Oh, it goes right through the 90. Look at that. It's right there on the 90. Okay. So let's put a box there. And let's mark that a 90-degree angle. Okay, all four of those are going to be 90. So we've got 4 right triangles in there. All right. And then, of course, something to bring back that we just did. Since this is a parallelogram, you're going to now have to remember that, remember, the diagonals bisect each other always in a parallelogram. So we're going to carry over that property to this parallelogram because it's indeed a parallelogram. It's just a rhombus. So make sure you mark those from the previous one. Okay, now it says measure the angles at the diagonal. At one of the vertices, so just at one of the vertices. So I'm going to go to vertex D over here, and I'm going to measure that. That looks like it's about, looks like it's about 70 degrees, and they are both, that one is right at the 35. So this is 35 degrees, and the whole angle was at 70, so that is also 35 degrees, okay? Then what did we just learn about opposite angles in a parallelogram? That they're congruent. So guess what? This is going to be 35, and this one's going to be 35. And then what did we also just learn about consecutive angles? So like this entire angle right here compared to this entire angle is that they are supplementary. So if this is 70 degrees, what's this whole angle DCB? Angle DCB is, if this is 70, 110 degrees. So if this whole angle is 110, what do you think each one is going to be if these came out to be the same? We'll just measure to confirm. But yep, it's right at the 55, y'all. So this is 55. That means this is 55. Which opposite angles are congruent? So that's 55 and that's 55. So now this is something that you're going to have to know whenever you come up on a problem that is a rhombus. So the diagonals of the rhombus are perpendicular bisectors. The diagonals of the rhombus are perpendicular bisectors. And then the angles, conjecture, the angles, the diagonals of the rhombus bisect the angles of the rhombus. Okay? So the diagonals of the rhombus bisect the angles of the rhombus. So all these properties you now have to know. All right, let's go to the next one, the rectangle. So it says construct a rectangle using that graph paper that I printed for you on your notes page, okay? If you don't have it, then you can use your notebook lines and just do the best you can to make it 90-degree angle. You can use your protractor if you have that. Then it says make sure you draw both diagonals and then compare the lengths. Okay, so I'm going to use my segment again to draw each diagonal. So everybody use your ruler to draw each diagonal. And then it says compare the lengths of these diagonals. So I'm going to get my my compass out, because I like to just measure with my compass. So I'm going to put my end point on one. Watch it not be big enough. It's not going to, so I'm going to have to get my ruler. And of course it's not. So let me get that out of here. So I'm going to get my ruler, and I'm going to measure in centimeters. You could also use the graph paper to measure it. So that's like about 12.4 centimeters. And then this one here Oh, what do you know? It's also about 12.4 centimeters as well. Don't have it lined up right at the vertex. Yep, there it is, 12.4. And then to remember all the properties, because remember the rectangle is another special parallelogram. Okay, again, we learned this all back in chapter 1. So since the diagonals are congruent, you now have to mark tick marks on all 4 of those segments. Okay, because remember the diagonals bisect each other in every single parallelogram. Okay, and then let's just recall the properties of a rectangle. Remember, opposite sides are congruent because it's a parallelogram. Each angle is 90 degrees, but let's also mark here that remember this angle is this going to be the same as this one, which is going to be the same as this one, which is the same as that one. And then make a different color. This angle is the same as this one, which is the same as this one, which is the same as this one, because you have some isosceles triangles in here. So I just want to definitely point that out, okay? So I've got every angle marked, okay, except for the ones at the center, but you know about vertical angles. You know vertical angles are congruent. So let's just focus on the diagonal conjecture. The diagonals of a rectangle are congruent and they bisect each other, okay? And that's just stating from previous knowledge from the parallelogram. So those are going to bisect each other, and that's it for the rectangle, okay? So be able to solve for any angle inside here, okay? Keep in mind, you know this, but that you have a right angle there, which means you have some right triangles in there that you'll have to work with. And then, of course, isosceles triangles. So we're just marked everything we already know. Okay, so the last special parallelogram is the square. And so we're not going to really construct anything here, but we do need to recall a few things. A square is going to be a regular parallelogram. Remember, regular means all angles are equal and all sides are equal. It's also referred to as an equiangular rhombus. Okay, so it has all the properties of a rhombus, but yet it's going to be equiangular. Because in a regular, in a rhombus that we already talked about, the angles were not equal. Only opposite sides, only opposite angles were. And then it's also referred to as an equilateral rectangle. So it's the rectangle that we just did, except it's going to be all sides equal, because that's what equilateral means. Therefore, all of the properties of the above stated polygon, so the parallelogram, rhombus, and rectangle, hold true for the square. So all we're going to do is we're going to sketch every part in the square, okay? But I do want to make sure that we draw on the diagonals first. So let's sketch the diagonals. Okay, remember it doesn't have to be perfect. We're just sketching here. Let's go ahead and first put tick marks on all 4 sides, just so we can clarify that, because we are dealing with a square. And then let's just start recalling. So the diagonals bisect each other, right? And then since this is also known as a rectangle and they were congruent, therefore these are all congruent to each other. So let's put tick marks on there. Okay, and then recall in the rhombus. In the rhombus, we had perpendicular bisectors of the diagonal. So that means we have a 90-degree angle at the center. I don't like it. All right, so that's a square there. So those are 90. Don't forget that the diagonals bisect the angles. And so you know every angle is 90 degrees, right? So then that puts every one of these angles at 45, okay? So those are all 45-degree angles. All right, and I think I've got everything marked. The diagonals are congruent. They bisect the angles, they bisect each other, and they are perpendicular to each other. So let's fill in every blank there. Diagonals of a square are congruent. They're perpendicular bisectors, and they are also the angle bisectors of the square. So you have a bunch of right triangles in there. In fact, you've got the special right triangle, the 45, 45, 90. Okay, so those are all the special parallelograms. Let's now see how you would see them in a problem example. So up here we said it says DEFG is a parallelogram. So let's go ahead and figure out all these different measures. And this is the way it's going to be. It's going to give us certain measures, and then we're going to have to solve for different sides and different angles. So measure of angle EFG. So E to the F to the G. So I need more information. I need to figure out what this is. So what I like to do is I like to use what's given and then just start solving for each angle, okay? And again, you're going to have to use a lot of previous knowledge as well. So one thing that I notice is that this is 55, so I'm going to just mark 55 over here, and I'm going to mark the angle right next to it. So if that's 55, that means this one must be 125, okay, because those are supplementary. And so if this is 125, I now see a triangle up here that leads you to this angle over here. So I'm going to use my calculator because I'm not very good at mental math. So 180 minus the 125 and minus the 24 leaves me with 31. So this angle right here is 31 degrees. So this whole entire angle over here is 106. Okay, so I'm just going to write a 106 outside just so I know. Because remember, consecutive angles in a parallelogram are supplementary. So if this is 106, guys, then y'all should know that this entire angle over here is going to be 74 degrees because 106 plus 74 is 180. So if this whole entire angle is 74, then that means this angle right here, I'm going to subtract the 24 from 74, and that leaves me with 50 degrees. All right, so I'm missing some angles down here. Remember, this whole entire angle is going to be 106 because it's same as the opposite. This one's going to be 74. And then we had also talked about, remember, opposite sides are parallel. So let me get a different color. This angle right here, this 24-degree angle is the same as this one here because those are alternate interior angles. So remember, this is 24, which means this one over here is 50, the same as that one. This one's 31, which means this one over here is 75. Those are all alternate interior angles. Okay, so I filled out a lot of angles. Oh, one last thing. I noticed that the segments given, this is 4 feet, so then this must be 4 feet as well, because remember the diagonals bisect each other. If this is 5 feet, then this one over here has to be 5 feet as well. So let's see, now that we filled out a lot in the picture, let's see if we've got pretty much everything figured out. So the measure of angle EFG, E to the F to the G. So yeah, this whole one right here, that's going to be 106. HGF, angle HGF. H to the G to the F, 24. See, that's why it pays to fill out every angle. Measure of angle DFE. 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 That's this one right here. So that's going to be 75. HF. How big is HF? 4 feet because the diagonals bisect each other. EG. E to the G. That's the whole entire diagonal. That's going to be 10 feet because they're 5 and 5. And there it is. That's a parallelogram. That's how you figure out each angle measure. Let's go to this next one. It says, what are the lengths of the diagonals? Okay, so you definitely want to draw in the diagonals. So here's diagonal 1, and here's diagonal 2. Let me get my pen. And so if this is 70, guys, remember the diagonals bisect the angles in a rhombus because this is a rhombus. Remember, all 4 sides are congruent. At the center of a rhombus, you need to remember that they're perpendicular, so draw a right angle right there. This is 35, so this is 35 over here. And I know this is 12, and I have an angle. These are all right triangles, so guess what we're going to have to use here? Stuff from chapter 12, trigonometry. Okay, so I'm going to use this 35-degree angle and the 12 to figure out this side and to figure out this side. So let's do this one first. Okay, I'll call X, which remember, it's the same length as that one because the diagonals bisect each other. So this is adjacent and that's hypotenuse. So this one, I'm definitely going to have to use cosine. So cosine of 35 degrees equals adjacent over hypotenuse. So let me use my calculator now. The variable's on top, so I am going to multiply 12 times cosine of 35, which I'm going to press 35 cosine. So this is x is about 9.8. Okay. Let's go 9.83. Let's round to 2 decimal places. So if that's 9.83 and that's 9.83, there's one of my diagonals. So I'm just going to hit times 2 in my calculator. So that's about 19.66. 19.66, and we are in centimeters. All right, let's go find the other diagonal. Let me get a different color here. So I'm going to call this one y, which is going to be the same over here because the diagonals bisect each other. This is opposite now, and this is hypotenuse. So opposite and hypotenuse is sine. So I'm going to do sine of 35 degrees equals opposite over hypotenuse. So let's use our calculator again. 12 times 35 sine equals 6.88. So the y is about 6.88. And then don't forget you have 2 of them. So I'm going to just hit times 2 in my calculator. And the other entire diagonal is going to be about 13.77 after you round to 2 decimal places. And there's your both diagonals. So you want to utilize those right triangles, okay? All right, let's go to the next one, last page, last ones of examples. So I have a rectangle and a square left. So I've done one example from each shape. So I got to find side B, and I got to find some angle measures here. Okay. Well, the only thing I know is that this is 12. So I know this is going to be 12 feet also because the diagonals bisect each other. So that's 12. And then I have this 10. What can I use? Well, I know it's 10 over here on this opposite end. So to figure out B, you should realize, oh, it's part of this shape right here. Okay, and this shape is a right triangle. So in order to figure out B, guess what we're going to do? We're going to do Pythagorean theorem because the hypotenuse is 24 and this leg is 10. So I'm going to do 24 squared minus 10 squared equals B squared. And I'm going to square root at the end. So I'm just going to use my calculator now. 24 squared minus 100 is 476. And then I'm going to square root that. So B is about 21.82. All right, so 21.82. Okay, so now I need to try to figure out what an angle is. I have no angle measures whatsoever. Here's a big mistake. A lot of people are going to say, oh, x must be 45 because the diagonals are always going to cut it in half. No, this angle right here is definitely bigger than this one, okay? So what do you think we're going to have to do to figure out this angle? Well, remember, we did draw that right triangle. We knew the hypotenuse and we knew this leg right here. So guess what we're going to have to do? We're going to have to use trig. So to figure out angle x, this is adjacent and this is the hypotenuse. So I'm going to use cosine. So cosine of x degrees equals adjacent over hypotenuse. Okay, so see that trig doesn't go away. You need to keep that in the back of your head. So I'm going to do 10 divided by 24 equals, and then I'm going to hit inverse cosine because you always have to do that when solving for an angle measure. So angle x is about 65.4 degrees. So I'm going to round to the tenths place because I don't like rounding to the whole number. 65.4 degrees. Well, keep in mind, remember diagonals are congruent. I forgot to mark that earlier for y'all. But these are all 12, which means this is an isosceles triangle. So if this is 65.4 degrees, that means this is 65.4 degrees. And therefore, you can use your 180 rule to solve for angle y now. So I'm going to press times 2. So I get 130 minus 180. So I get about 49.2 degrees. Okay, so I use the 180 rule for this triangle right here. Okay, last one, the square says solve for some sides and some angles, and I only know this little part of the diagonal. Okay, well, if that's 8, you should know that this is 8, this is 8, and this is 8. You also know that these are 90-degree angles right here. You also know that these are all 45 degrees. Okay, so I'm not going to mark all of them. Just going to mark a few. And now I got to start solving for some other. Well, let's do the angles. The angles should be easy. So the measure of angle SUE, S to the U to the E. Well, diagonals make 90-degree angles, so that's 90. And the measure of angle QRS, and that one's going to be 45. All right, so the angles are easy. The sides are a little bit tougher. SQ is this one over here, so I'm going to just put a question mark there. Use a different color. I need to find SQ. QE, where's QE? QE should be easy. Let's go ahead and answer that because we have filled that out. So that's 16. And UE, well, there we go. UE we got also. So the toughest one is going to be this one right here. Well, what kind of shape do you see here? You see a 45, 45, 90 triangle. So if you have a great memory, when the legs are 8, what is the hypotenuse? Hopefully you remember it's going to be 8 radical 2. So that'll save you some time if you remember your special right triangles of 45, 45, 90. If not, guess what you can always do? You can do 8 squared plus 8 squared equals c squared. And then you can square root, and you can give the decimal as well, okay? So what is that? What's 64 times 2? And then square root. That is about 11.31. So if you were to give me the decimal answer, you will get it right also. Now, if there are on your multiple choice answers on your test coming up soon, and they're all in radical form, well, you can just punch that into your calculator, and that'll convert it to a decimal. Alrighty, and that is it. Those are all the examples.